Hello and welcome to the Reuse Company webinars. If you have any questions or comments about today's topic, you can use the question section anytime during the presentation. We will have some time for Q&A at the end of the webinar. The webinar will be recorded, and in a few days we will send you the link to the recording. The topic for today is Semantic Traceability, a passport towards a digital thread without boundaries. And today's presenter is Jose Fuentes, and my name is Cecilia Carlson. So what do we do at the Reuse Company? Our company is a solution provider specialized in the application of semantic technologies and artificial intelligence to improve the digitalization of the systems engineering lifecycle. Jose Fuentes is our presenter today. He is the Chief Sales Manager at the Reuse Company. He has the INCOSE CSEP certification and has graduated from the INCOSE Institute for Technical Leadership. He is a member of the board of AES, the Spanish chapter of INCOSE, and he's an active contributor to the INCOSE Guide to Writing Requirements. So let's start with today's topic. Good morning, Jose.
Good morning, Cecilia. Good morning, everyone, or good afternoon. I see some names here that I believe that are making an effort in connecting from their afternoon. So thank you for joining me. Today, the topic is, as Cecilia mentioned, the traceability. So I will start with some basic concepts about what is traceability in different contexts. Then I will introduce our tool, the Engineering Studio. Is part of the Systems Engineering Suite, and how we understand traceability in this tool. And after that, I will speak a little bit about the Interoperability Hub, which is the next step on top of our notion of traceability. Finally, we will have a practical demonstration with a video that I recorded, covering most of the important aspects of the tool. And we will end up with a Q&A section where I will be happy to address all your questions, right? So let's go right to the point with first a basic definition. In a normal world, let's say, for every citizen, what is traceability, which is just the capacity to find and track where a product was made, what were the raw materials that were utilized for the fabrication of these components, and how it was produced, where it was stored, and how it has been released, and all this all along the supply or the logistic chain. So this is traceability, and of course, from beginning to end, or from end to end, depending on your language. And this is kind of what is expected in many other more technical disciplines, like I am a software engineer, so sorry for that, but I sometimes refer to all the software standards like this 830, telling us that the software requirement specification is traceable if the origin of each of its requirements is clear, and if it facilitates the referencing of each requirement in future development or enhancement documentation. So this is what we will try to accomplish. Of course, more definitions also speaking about verification. So a requirement is verifiable if and only if there exists some finite cost-effective process with which a person or machine can check that the software product meets the requirements. So somehow we can see here different, let's call it traces or links somehow. First between different levels of requirements, and then between requirements and verification actions, to put it in this name following INCOSE naming now. So if we just stick to these basic definitions, it could seem that perhaps bi-dimensional table like this one, a regular matrix, is enough, right? Where you can find requirements here on the top, and use cases here on the left, crosses telling us that there are some requirements to test some tests to verify some specific requirements in our system. So this could be enough. Well, it depends. Could be enough as a first step. Allows to check where every requirement is coming from. If we have other similar matrices to trace between perhaps user needs and requirements. Allows to check completeness of tests. It's clear that it does ensure that the implementation meets specification whenever all these tests are successfully passed. Could be enough for some small projects, small software projects, but clearly it's not enough in complex projects. It doesn't support the requirements decomposition or design. We will speak later about the directions of traceability. And of course, because of all these reasons, it doesn't satisfy standards like ARP or DO or ISO 26262 or many others, right? If we focus on one of these standards, the ARP 4754, then it is telling us that the process should include or should meet some of these goals, like requirements management processes, including traceability and processes for allocation, requirements verification and validation, change management. It is only because of the proper management of these traces where we will be capable of understanding what is the actual impact of potential change coming to our specs. And more and more in the same discipline, like this other section of the same IRP, telling us that the requirements that are defined to prevent failure conditions or to provide safety-related functions should be uniquely identified and traceable throughout the levels of development. That's why we need, let's say, some sort of more professional tool if we want to prove that these requirements, our requirement sets, are sufficiently correct and complete, and the final product is meeting the customer needs, right? So we need professional tools, because this is a demand coming from many functional safety related standards, like all these that are listed here, and some other ISO standards like the 13485 or the 26262 for automotive equipment, right? So, so in the end, what we find normally is that traces or traceability is not just a matter of two-dimensional table, regular matrix, and somehow, of course, most of the tools that we are all using regularly, like if we use requirements management tools or ALM tools, PLM tools, or even MBSE tools, most of these tools already covers or provide us with capabilities for traceability. And these traceability capabilities are fine and are sufficient most of the times. However, what we find is that also most of the times one tool is not enough as to cope with all the full life cycle from the, let's say, very high level user needs or user requirements, regulation that many times comes under the form of PDF files, system and subsystem requirements, conceptual modeling, physical modeling, risk management, safety analysis. All these most of the times require different tools. So this is where normally companies detect problems in tracing when the traces need to go beyond a single tool, right? And this is something that I would like to show you today, because at the end of the day, the first step is, of course, to identify this kind of map of potential traces. So this map here is representing my project. But in the end, the traces are not just the link between the boxes, because if we put closer this magnifier glass, then what we see is that traces are actually links, not only links between the boxes, but links between the different configuration items that are stored or managed into any one of those boxes, right? So that's why we need advanced tools capable of connecting to different tools, because in the end, one of the first aspects to consider when it comes to traceability is granularity. Granularity when the items to be traced are managed in a requirements management tool, in an ALM or PLM tool, then, well, it is clear that the proper level of granularity for traces is each one of the configuration items managed by these different types of tools. However, when it comes to tracing to models, then now we have different options. We have the option to trace to a given full model, diagram, perhaps a state chart could be entirely treated as an item to be traced, or we can go more in detail to the different model elements within these diagrams and these models, right? So you choose. At the end of the day, you choose by means of, in the case of MBSE tools, you choose by means of UML or SysML relationships, which is the level of granularity of your traces. And of course, things get even more complicated when it comes to non-structured sources. Believe it or not, but of course, real life is full of, especially full of PDF content. Sometimes our customers will provide us with their stakeholder needs and requirements in PDF, but mainly regulation is normally given to us within a PDF. So we need a means first to parse what are the meaningful elements in these PDF files, so that we can consider that those meaningful elements are now configuration items to be traced into a traceability management. And this is what I will try to show you today during the practical demonstration. I will, part of this demonstration will include the parsing of a PDF file, the extraction of the meaningful blocks, and how we will be capable of first tracing these elements all together with requirements and risk and test and many other elements that you will see. And we will be capable of detecting changes in this PDF and how these changes impact in many other elements along the life cycle, right? So all this will be the practical part of this. At the end, so why do we need all this number of different tools that I was mentioning? Mainly because a complex project is built up on top of a large number of the so-called lifecycle concepts from high-level needs, standards and regulations, risks, high-level concepts, high-level requirements, low-level requirements. So there are plenty of different types of elements, normally managed by different tools, each one of them, and normally with different semantics in the way all these different elements are connected. That's why another important topic, together with granularity, is the notion of type of traces. So we need to identify the semantics behind any of the different types of traces that we create with our tools. And this is also part of what you will see today in this practical demonstration. And then speaking about types of traces, another differentiation in the way we name the traces is the differentiation between horizontal traceability and vertical traceability. And here I have seen different standards naming things in different ways, right? While there are some people who name all these traces like horizontal traceability. This is, for example, the definition used nowadays by INCOSE, where all these traces along the supply chain from the set of needs, the consolidated set of stakeholder requirements, system requirements, subsystem requirements, architecture, design, and even tests to verify our system. INCOSE calls to all these relationships among all these elements in the life cycle are named like horizontal traceability, right? In other standards, everything which is connected to the left-hand side of the V, the connection between all the elements related to the left-hand side of the V are called horizontal traceability, while the verification or the traces linking verification actions or tests with our requirements is what is called horizontal traceability, while the left-hand side is called vertical traceability, right? So as I said, depending on what your reference is, you will find perhaps different names. But the name according to INCOSE, is that all these traces, both in the left-hand side, but also the verification traces from right to left, is called horizontal traceability. And according to INCOSE, what is called vertical traceability is when it comes to the decomposition of our system. So initially, when we consider the first level of lifecycle concepts and needs and requirements, we will be describing with this our system of interest, the complete system of interest, let's say initially as a black box, that we will start with the first level of the composition here, represented by these three subsystems, right? And of course, for each one of those subsystems, once we have decomposed the main system, we will carry on with the same idea of lifecycle concepts, needs, and requirements, and so on and so forth until we stop the decomposition. Normally, it is said that we will stop the decomposition where the given system element is easily enough as to take the decision if we want to make it, reuse it, or buy it, right? So whenever the level of granularity is enough as to make an easy decision in this line, then we stop decomposing, right? And then, as is represented by all these blue arrows, there need to be relationships or traceability relationships between the element at the different layers, right? And all this is what INCOSE is calling vertical traceability. So we need, at the end of the day, you name it in one way, you name it in the other way, it doesn't matter. The idea is that your traceability tool needs to support both levels of traceability, all the levels of traceability described in this slide, mostly the recursive decomposition, plus all the different relationships, traceabilities described in this other slide, all of them need to be managed by your requirements management tool. So at the end of the day, what we find is that traceability management is a must, of course, in every complex and safety critical project. It is requested in many standards and good practices guidelines like the ISO 26262 or the IRP 4754 that I was mentioning, but many others, depending on your field. It provides visibility in complex projects. To me, this is a must. The possibility to ask a project manager, okay, what is the level of development of our system? And for him or for her to have a clear answer to us. All this is based also on traceability. If there is no traceability, we will not be capable of understanding this, and we will end up with gold plating or scope creeping or all these creepy names that we give when the project is not under control. The project is going in one direction, and we, the team, are going in a different direction, and we are in a trajectory of collision, let's say. So this is a must, as I said, and we need to do it. However, it is normally a tedious and manual task. It involves a connection of tools that are not intended to be connected sometimes, because as I was mentioning, we need to connect configuration items from different tools, and it has to be aware of changes and the evolution of our project. So that means that we need pretty much not complicated, but a very complete tool to deal with this. And the one that we offer in the reuse company is the so-called Engineering Studio. This is part of the Systems Engineering Suite. So the Engineering Studio includes a multi-source traceability tool. So this is the main characteristic of the tool. So that means that it is not that all the configuration items are created and managed within this tool, but on the contrary, the tool connects to plenty of different sources. We will see this point in a minute. So Engineering Studio can open several documents at the same time in the same window. You will same screen. You will see it during the demo. Traces generated and are maintained into our interoperability hub, which is, by the way, an ontology. Traces can be synchronized with the tools where the configuration items are created. That means that you can manage traces on our ontology, but these traces can be synchronized with traces in, in your requirements management tool or in your MBSE tool. We will see this also during the demo. And of course, closed platform, other characteristic like closed platform traceability management, dynamic traceability matrices, semantic impact analysis, flexible reporting, semantic suggestion of traces. This is something that we will cover slightly today as well, and import and export of traces into native sources and into many other formats, right? So perhaps you will wonder, well, and now how can I, if when it comes to create traces between different tools, how can I do that? So this is basically the user interface of the Engineering Studio, where, as I said in the previous slide, you can open 2 or more documents at the same time. So now I have opened, according to what I see here with the icons, I have opened system requirements document in Word, right? Where we are capable of parsing the content of this Word document to extract requirements and to highlight requirements in here, right? With the possibility, of course, of establishing traces, as you will see. And on the bottom right part of the screen, now I can see that I have also connected to architectural elements in Capella, right? So how can I trace Word and Capella? Very easy. You open both at the same time in the Engineering Studio. You select what is the type of trace you want to create. We have spoken about types. So in this case, it's realizes, which goes from one system requirement. So I select the system requirement I want to trace to one model element. I select the model element I want to trace, and then I click on the trace button, and my trace is created. So as simple as that. And this trace will be stored into our ontology, together with the rest of traces, possibility to see the impact analysis, to draw matrices, and so on and so forth. You will see all this during the demo. And today, the idea is that we have something like 50 different connectors, around 50. And what you cannot expect in our system is to have point-to-point traceability or point-to-point connectivity. So we never create one-to-one connectors. On the contrary, what we do is we establish bidirectional synchronization between each one of the tools and our ontology, our hub. And by means of this is how we can establish traces between different tools, no matter which couple of tools you choose. And the additional good point of avoiding point-to-point connectors is that if, I don't know, tomorrow, one of you require, okay, I want this approach, but I am using a tool that is not in the list of 50 tools. If we just create this bidirectional connectivity between your tool and our ontology, then that's all you need to do in order now to trace between your tool and any of the other 50 tools already connected to the interoperability hub, right? So this is the idea. And another important topic when it comes to traceability is the so-called zigzag pattern. So zigzag pattern is not described by us. You can find a lot of information about this zigzag pattern following this link here on the top left. But at the end, it goes something like, okay, I will start writing my textual requirements. Firstly, I will see requirements for my full system. In this example, it is a car, and I see the car as a black box. So what should I expect out of a car as a black box? So I start with this document, but with the first arrow to the right, then I jump from the textual requirements into, let's say, MBSE world, where I start with the first level decomposition of my car. So now my car is made up of different blocks like engine, chassis, and entertainment system, right? So this is the first level decomposition. Now, if we go back to the left, then we will see that now I consider each one of those each one of those elements, and I will consider them as a black box, so that I can write requirements for in this case for the engine. So I have chosen the first block, the engine. So I write requirements for the engine, like the power of the engine, the size of the engine, the power consumption of the engine, and so on and so forth. And then I move to the right again to build up the next layer of the composition for the for the engine. In this case, is for one specific type of engine, according to this generalization and specialization relationship. This is not the engine itself. It is representing one particular type of engine, which is hybrid engine. So that for this hybrid engine, I consider three main blocks like battery, the engine itself, and the control system. And then I continue with the decomposition and the requirements. So go to the left, write the requirements for the battery of this hybrid engine, and I continue left to right, left to right. So in this classical approach, you have different choices. One is to do both requirements and models in a modeling tool. Well, this is something that I have seen in many cases. However, normally tools like Cameo and Capella and some other MBSE tools are good for modeling, but not that good to manage textual requirements and to offer all the characteristics that a professional requirements management tool normally offer, right? So that's why in some other cases, requirements, the source of truth for the requirements relies on a requirements management system, and the source of truth of the model relies on an MBSE system. However, when you separate the source of truth for these two important aspects, then it comes now the question, how can I trace? Answer, if you separate, then of course a tool like ours allows you to establish traces between different tools. The other option could be develop your requirements in a professional requirements management tool, baseline your requirements, and now somehow synchronize your requirements to the modeling tool, evolve these requirements definition, create architecture, perhaps derive new requirements from architectural decisions, modify slightly your requirements when needed, create this first layer of architectural items, trace and allocate requirements to these architectural elements by means of UML XML relationships. And now all these modifications in your requirements plus the traces move them to the proper tool. And that is the modification of the requirements can be synchronized back to your requirements management system, while the new traces that you have created in your modeling tool, like UML XML associations, can be also transferred to our ontology that will represent the source of truth for the traces. So in this case, in this game, there would be three main sources of truth. A requirements management tool, like the source of truth for the requirements, a modeling tool, like the source of truth for your architecture, and our ontology as the source of truth for the traces among them. And by means of our tool, we allow for all this zigzagging and all this synchronization that I was describing here can be managed in our tool. Moving the requirements, moving the traces, all this can be done with a click of a button. If you need to learn a little bit more about this approach, when you get the slides for this presentation, this is a link to a full webinar where in 1 hour I describe this zigzagging, and I show the zigzagging with the tool, right? Final point about our traceability capability is the notion of semantic. I have mentioned semantic many times, right? So why do I call this semantic? Very simple. Normally, when you get a requirement, you will get the ID, you will get the text itself of the requirement, and you will get plenty of different attributes, right? So most of the tools, they take the requirement as it is, basically as the ID. The ID could be sufficient just to establish the traces. However, we like to understand what each one of these requirements is meaning, right? And we like the notion of pattern. So a requirement like this that says when ice is detected, the car shall show an ice icon in less than half a second from its detection. By means of these patterns, this requirement, these textual requirements, is further decomposed into a semantic graph. And in the end, what we store in our ontology is the semantic graph. Transforming this requirement into a semantic graph allows us for plenty of different algorithms, for instance, to detect duplicated requirements or to detect requirements in different documents that need to be connected. So the tool will be capable of suggesting traces for you, as I will show during the day. So, and now what? Once everything is well connected, so what should be the next steps? So we have come out with something that we call Interoperability Hub. Of course, traceability is part of this Interoperability Hub. However, this hub is not only the notion of connecting to the 50 tools or providing semantic traceability. We also implement other notions like synchronization of information between tools, transformation of elements, for instance, from one model, from one diagram, create the textual requirements corresponding to this diagram, or the other way around. We can what we call bind products from different tools, so that changing in one tool could trigger changes in a different tool. And we can do this even in remote IT environments or IT infrastructures to provide collaboration between different companies. All this approach of the Interoperability Hub was also described a couple of months ago in a webinar conducted by my colleague, one of my colleagues, Ilyes Yusfi. And if you get the slides, just click here to watch a 1 hour webinar describing all this interoperability approach, right? So now, having said that, by the way, if you have questions, don't hesitate to start asking your questions in the question box that you have in the right-hand side of your screen. Go to webinar screen. You have a chat section, but also a question section. Please do not hesitate to start typing your questions from now, and I will address all these questions after this video. But now let's go to the video. Here we are. Cecilia, can you see the video as well?
Yes, perfectly well.
Okay, good, thank you. So this is the Engineering Studio, and the first thing that I'm gonna do is I will connect to the different sources that I want to connect. Right? I will try to build up something similar to what I built up or what I presented in one of my slides, with requirements in DOORS, with user requirements in Excel, with regulation in PDF, then enterprise architect for modeling, and some other sources, right? So, so in this very simple way, you can connect our tool to a DOORS document. You just provide the server and your credentials, and then you are done. You are connected. If you need to capture also additional attributes, then you just go to this screen, select the document from within the project, and then you can choose which attributes you want to take from the source, like the priority, status, and some other, right? You give a logical name for this connection. So this is your name. And with that, you are done. So of course, you only create this connection once. You can determine if you want this connection like a private connection, or if you want to share this connection with your colleagues. But in any case, for any other colleague willing to open this document, they need to provide those credentials. If not, you cannot enter into your document. And now everything is done. So you have established for the first time the connection. All this green column is telling us that this is the first time this document gets into the repository, and the new, the state repository column with all this in green with the new label means that it is not until I save that the ontology, now is when the ontology realizes that there are 172 new elements in this document. Right. So similarly to the way I created this connector, I can create other connectors to other sources. Let's continue with Excel now, because I was considering in my example that a consolidated set of stakeholder requirements is coming in Excel. So I connect to this Excel document. The Excel document is not mapped. I mean, we need to understand what is the meaning of each one of the columns. So we go quickly through this mapping wizard. And well, I don't want to check the quality for these requirements. And I can choose which additional columns, if any, I want to see in the Engineering Studio as well. And I'm done with the mapping. So now the icon is dark, and I just go provide my logical name, and click OK. So the connection is established. As I mentioned before, you only need to go through these steps once, right? So once the connection is created, the box is created, you can just open it by double click. So similar idea, everything is new for the system. So everything appears with this green label, and I now save, so that now the ontology will realize that there are 68 elements like stakeholder requirements in this document. So I have two documents, and I can, with this Engineering Studio, I can open both at the same time if I wish, right? And this is what I have done. So to the left, the left-hand side of the screen now shows the stakeholder requirements, and I can make now that the system requirements appear to the right. But first, I have created my first traceability project, and within this project, I'm creating now a traceability module. I need to create as many traceability modules as you wish, linking the different documents that you have connected. In this case, the type of this link module is derived, and it goes from the stakeholder requirements to the system requirements, right? So I allocate my screens. By the way, if you have two physical screens, then you can dock these panels in two physical screens. But since I had to record the video, then I need everything fit into one single screen, right? And now the map of my project is far more smaller than the one I was presenting in my slide. Only two boxes and one arrow, but okay, let's grow it. First, as I said, we have established the link between the documents. Now we need to establish link between the actual configuration items within these documents. So how can I do that? Simple as I was describing in my slide. I select one element on the left, I select one element to the right, and I click on the trace button, and I'm done. So with this, a new trace is created. Where is each one of these elements living? The stakeholder requirements relies still in Excel. If there is any modification, it will be in Excel. My system requirements relies in doors. If there is any modification, it will be in doors. However, the traces, and now I am creating traces just with double clicking on each one of those rows. So these are dynamic traceability matrices, and I can create as many traces as I want just by clicking on this matrix. So all these traces will be stored into our ontology, right? So I can now, if I consider that I'm done, of course, we have options to detect orphan requirements. So this is not the end of the story. I am trying to make a long story short, but we have options to detect orphan requirements and to quickly see that there are plenty of stakeholder requirements without the proper system requirement. Now, I am connecting to a non-structured source like a PDF. So let me show you the PDF. This is a fictitious standard that we have created, 99999, good number for a new standard, about electrical components and wiring and this kind of thing, right? So this document includes, along the different pages of the document, includes some shall sentences with the mandatory blocks of the requirement. So we will make use of these shall sentences to parse properly the document. So I will say that I want to identify each one of the meaningful blocks with this prefix and 2 digits. And even if we provide different means of parsing, advanced mechanisms, some of them, I will just use a very basic one that says whenever a paragraph includes a shall into the paragraph, then this is going to be a configuration item, preliminary at least. As I did before, I give a name to this document, and the connection is done, right? And now, once the connection is done, similarly to what I did before, double click, and now the tool opens PDF, parses the document, extracts the shall sentences, provides a unique and fixed ID for each one of those elements, and that's all. You see again the green column here on the left. And then, of course, I can create a new traceability module. In this case, the source of this trace will be the regulation, and the target will be the system requirements document indoors. By the way, I have chosen those as I could have chosen Polarion, Codebeamer, Elix ALM, or even Word, when Word is treated with our Rex add-on, so that you transform a Word into a professional requirements management tool. So the traceability module is created, and now, as I did before, I save the content in the repository before traces can be established. You need first to identify or to inject these elements into the repository, and now you choose your stakeholder requirement. You choose your regulatory aspect, which is at the right-hand side of the screen. You choose your system requirement on the left, and you click on trace, and that's all. So this is the way to create traces between PDF or fragments of PDF properly identified and your system requirements in Word, in DOS. Of course, there is an advanced filter, there is a basic filter like this, so that you can identify the elements you want to trace and continue tracing, or you can import traces from Excel, or you can use the matrix, or you can suggest, as I will do in a minute, right? So these are the traces that I create. So I move forward a little bit, and the map is growing, right? So let's continue now with more requirements. In this case, my system requirements, I have, this is double speed, and I am moving forward because I am creating two different connectors to two of the subsystems of my system, right? And now I can create traces, derivation traces between the document representing my full system of interest and one of the subsystems, which is the power system in this case. So I have the system requirements on the top, I have the power system requirements at the bottom, and I can create as many traces as needed just with clicking here and there, right? But now I will connect to another of the subsystems, right? To provide you different possibilities and more advanced possibilities, not just manual traces, but a series of advanced possibilities. So now I have both the so-called TW system requirements, temperature ward system requirements, and the control system, which is a subsystem. So first, I create the traceability module between both. And I will say that I can choose between any of these three different types of traces. I identify the source, I identify the target, and now, since both the source and target, I pause for a second. Now, since source and target, go back a minute. Source and target are doors. It could be that there is already a doors link module connecting these two documents, right? And this is what the tool has detected. The name of this link module is derived. So the tool is asking you, do you want to synchronize traces in the Interoperability Hub with the traces already created in doors? If you tick this checkbox, it means yes, I want to do it. So I have done it, and just to show you quickly that there is a link module called derives connecting these two documents, and of course there are already. If I open the TW document, there are already some traces between some of these requirements and the requirements in the control system, right? So these are the traces that have been already created in doors. So if I click OK, now I have the option to, when I open the detail of this traceability module, I have the option to import and synchronize traces from and to doors. So all these traces that have been created, 12, were coming from doors. In green, the state, meaning they were not yet in the repository until you click on save. When you click on save, now our ontology can I post now our ontology. When you click save, our ontology now represents also these traces. Now let's continue adding more and more traces, but not manually. Now I will use the semantic mechanisms that I was introducing before to suggest traces. We have implemented some of them. You can even come out with these custom algorithms, means that you can also create your own code to do suggestion of traces. There is a complete development environment inside our traceability module, so that you can write down your code to suggest traces between two different documents, or one document and one model, right? In this case, I have chosen one which is called property allocation. So I have changed the type of trace to be created to allocate. And this algorithm is semantic algorithm, but it is not complicated. It just asks me to select a given what we call cluster in our ontology. In this case, the cluster representing properties, and one view of our ontology, which is the PBS view. PBS stands for product breakdown structure. So this is representing the name of the elements in the decomposition, let's say, of the full temperature water system, right? So by means of that, and considering that these two documents are at two consecutive layers of the composition, the tool is linking or is suggesting me to link this requirement, which is a system requirement, with this other requirement, which is a subsystem requirement. The structure of the requirement of both requirements is different, but the meaning, once we transform this into a semantic graph, remember my slide, these semantic graphs are pretty much connected. In this case, the semantic graph will be that the component temperature warrior has a property called power consumption with a given value, whatever. In this other one, the structure of the semantic graph is similar, also contains power consumption in one of the ends of the triplet, but the other triplet is not the power consumption, it is the control system, which is not the same element. However, control system, remember the second step in the configuration, control system is a child in the PBS decomposition, is a child of temperature warrior, and that's why the tool is offering me this as a potential candidate to be traced, right? All the traces that you generate with this algorithm, I don't know if you can see that there is a gray background until I accept, right? So whenever I see what is the content from both source and target, I have the option here to say, yes, I accept the trace, or no, I discard or reject the trace, right? In this case, I accept this trace. I can accept one by one, or I can accept all in one single step by accepting all the suggestions, or select some and accept all the selected. So plenty of different ways, right? And again, everything is still in green, meaning that it is not stored indoors, or it is not stored in our ontology until I click save. Well, another algorithm for suggestions. I have written a lot of my requirements following this particular structure, this particular pattern. You know that we love patterns. So I have a lot of requirements written in following kind of the, I don't know if you're aware of this, so-called EARS pattern. EARS stands for Easy Approach to Requirement Syntax, and it describes basically 6 different patterns, and one of them is telling us something like while a given agent or component is in a given state and something happens, a trigger, and when a trigger occurs, the system shall provide a response, right? So this is basically one of the types of requirements, and I have a lot of requirements following this same structure, right? So what I have done is by means of this pattern that I have selected here on the top, you can identify that there are name of agents, name of modes, and name of actions, right? So what I have done is, okay, I want for any potential candidate of couples of requirements in both documents to be traced, I need first to ensure that both source and target fit or match the same pattern first. And second, take the actual element in each of the requirements for the state, and I want it to be the same in both requirements. And also take the action, and I want the action to be the same in both requirements. By means of this and, I mean that these two conditions, you can establish and condition or condition. To be more precise, of course, I use the and condition. So when I click OK, then I will have the tool suggesting more potential traces. Now, two more in gray, still in a suggestion state, that I can go into detail. And then when I open both, I start with the first one. Of course, the mode is configuration mode in both cases, is the same mode. And the action is to request configuration. So I can say that, yes, I accept it. If I move to the second of the ones that has been suggested, it will occur something similar. Now the mode is in both cases combat mode, and the operation is measure the temperature, the physical temperature, right? And then the tool consider that these two requirements need to be connected, and then of course I, as a user, I can accept the suggestions, and I can save these suggestions both in our repository, and this is the most important, and in doors. So if I close all this and I open doors, I think it is not shown in the video, but if now I went to doors and open doors, I will see that there are two sorry, not two. We have suggested 2 + 2. There should be 4 new traces created in doors. Now I move faster a little bit because I want to create connectivity between my standard IEC 99999. I have identified some risk to address this regulation, right? So I have the standard still in PDF, and my risk in Excel. In this case, you can choose any other tool. So as soon as you create both connectors and create a traceability link of type I have chosen here, threatens, then with just click one configuration item in the regulation document and click one risk in the Excel sheet, and you have one new trace. Very quick and very straightforward. So let's continue, and why not change occur? So now this regulatory body decides that there need to be some changes in the document. So I have a new version of the document. The tool detects that there is new version, and it is asking me if I want to generate a baseline for the previous version. So I have said yes, I want to name this baseline V1. And now I can do things like comparing current in PDF with the former V1 version. So now when you open the PDF, you see a lot of red, green, and yellow lines. So all these items in of course, green means new content, red means content that has been deleted, and yellow means content that has been modified. So for instance, this regulatory body has decided to modify this requirement, which is speaking about the thickness of the rubber for the protection shield of the wiring, right? So I can do things like, okay, please tell me what was the value before. And now the tool is comparing current version with version 1, right? And it is telling me that it used to be 3 millimeters. Now it is 2.5. Oh, wow. 2.5 is minimizing one of the cost risk that I had identified in my risk document. And how can I check it? It's as simple as go to the traceability view of this PDF document, and the tool is telling you that this document is involved in 2 traceability modules, one connecting the regulation to the system requirements and the other one connecting the regulation to the risk. I ask the tool, please connect the risk, because I previously to this, I closed the risk document. Now I open it, and then I can quickly see what is the impact in terms of risk, or what is the impact in terms of my system requirements. If I check the box there, then you can see below, in the table below, that there is one risk that was connected to this particular element in the regulation, right? So now you decide, after you have checked the impact of this, then you decide if you just accept the change and say that this risk is closed. If there were system requirements already addressing this demand from the regulatory body, then of course you can do whatever you wish with this before you formally accept this change, right? So this is a graphical representation of the impact. That in this case it was very little impact. It was only connected to one risk, right? So you can rely on this graphical representation as many times as needed. So let's now move forward a little bit and go into models. Why not? I'm showing you here again more and more traceability matrices here and there, right? But since we are running out of time, now I'm connecting to a model. In this case, I've chosen Enterprise Architect. We have connectors to Capella, Cameo, Rhapsody, and some other MBSE tools for conceptual modeling. Also some physical modeling like PTC Creo and some others, right? So, and of course, for each one of these, you can connect local models, or you can connect models on the cloud, let's say, right? So in this case, to make this faster, this is a model in local in one of my in my hard disk. But as I said, the normal case will be to connect models on the cloud, right? So in a similar way as the way we are representing textual documentation like requirements, risks, or some other textual documents, the Engineering Studio is also capable of connecting now using the APIs provided by, in this case, Enterprise Architect. It is connecting to Enterprise Architect. Remember, this is not a modeling tool, but we can see in the Engineering Studio what are the content for this document, right? So I have the document open. I can create one traceability module to connect my system requirements to the architecture in Enterprise Architect. I will name this type of trace with the name I want, realizes, for instance, and the direction is from the requirements to the model. I always speak about direction and source and target, but once you establish one trace, there is a direction, but it is navigable in both directions, right? So we need to identify which is the source, which is the target. You cannot link things the other way around. If you need to think the other way around, you need two different documents, but each one of these traces can be navigated in two dimensions. So creating traces between a requirement endorsed and a model element in Capella is as simple as what we do normally. Just click on the left, click on the right, and create the trace. But now we also provide the possibility to analyze semantically the content of your textual requirements and also extract the name of the items in the model. And the tool is now suggesting that, for instance, if I have a requirement like this saying that while the temperature warrior is in combat mode, and there is an element in the model called combat mode, of course, what the tool is doing is the tool is suggesting me, please create a trace between the requirement and the mode or state in Enterprise Architect. I can accept all, I can accept some of them, so I can accept whatever I wish. Now the tool is replacing the status of all these 300 and something traces from suggested to accepted. And now that's why little by little our map is growing. It resembles a little bit more the one that I was showing you in the slides, where we have links here and there. The system requirements are connected to model in Enterprise Architect. The system requirements derive from both, from regulation in PDF and from stakeholder requirements in Excel and so on and so forth, right? So this map can grow with as many different boxes as you need. And considering now all these boxes together, you can do things like what we call global impact analysis. So you can pick one particular requirement. In this case, I have chosen an item in the regulation, and you can see how this item in regulation impact in 3 different system requirements, and each one of these system requirements impact or derives into subsystem requirements are also allocated in specific elements in the architecture and so on and so forth, right? So all this is what you get with the help of our tool. And finally, another way to represent this not only with by means of a matrix, bidimensional matrix, or by means of this graphical representation, we also provide a final way of seeing this impact, which is representing in different columns the different items that are connecting one to the other. The more traceability links and the steps you get, the more columns you will find in this C. In this case, you have column A, B, C. Column A represents items from the regulation. Column B represents system requirements, and column C represents either models or subsystem elements, right? So 3 columns to represent these 3 levels of the composition. And that's all for the demo part. I think I'm a little bit beyond my time, but I can stay here if you have questions. I will be more than happy to take some additional minutes to answer your questions.
Thank you very much, Jose. So if you have questions for Jose or comments, please write them down in the questions section. And while you're doing that, I will tell you a little bit about our next webinar. It's called Requirements Management in Word, Learn Fast, Collaborate Smarter. And here we want to show you how Word's easy interface is powered by the seamlessly integrated requirements management features of SIS Engineering Studio. Our add-in version for Word assists you to effective requirements management in all kinds of text documents and leverage team-driven and agile requirements engineering processes while avoiding steep learning curves. This webinar will cover shared document editing and requirements management, requirements quality, and traceability analysis, and a collaborative environment in change request mode and versions management. And the dates for this webinar are the 12th and the 13th of March. We will send you more information about this soon. So over to the questions. Can you identify orphaned requirements in the traceability module?
Yes, absolutely. We can identify orphan requirements globally in let's say in a document, which of the elements have no traces at all, but also for a given document, for a given traceability module, we can also do the same. So this is like more specific. While the first one identifies elements without any trace of any type, you can also go into the module to detect elements from source or element from the target that has this type of relationship that is established in this traceability module. Right? It is a more precise way, so you can do both.
Okay. And how are traceability types managed? Can the trace types be transferred across projects?
Yeah, good question. So first, all these, remember what I have been mentioning during the presentation. Everything or the core of all this approach is an ontology, right? So, so the traces types are specific types of relationships in our ontology. So we have different types of relationships of many types, not only traceability relationships, but there is a branch, a complete branch of types of relationships that are traceability relationships, right? So every project connected to the same ontology will be capable of sharing the types that you define. That, by the way, you can extend either with the traceability module or with our ontology management tool as well. So with both tools, you can extend or manage the list of traces. And if you needed to export these type of traces from one ontology to a different ontology, yes, we provide mechanisms in the ontology management tool. We provide mechanisms to export plenty of different pieces of information from the ontology, and one specific piece of information that you can export from one ontology to the other are the types of traces.
Thank you. How can the tool detect the impact of a deprecated or obsolete requirement in the traceability chain?
When a requirement, as I presented in the video, when a requirement for whatever reason is removed, it could be, in my example, it could be in PDF file, but it could be also in DOS or Polarion or whatever. The tool will first identify within the connector to the document itself before we jump into traces. So the first alert is shown whenever you open the document. So I open my PDF, and then I have red items in red, meaning, these items have disappeared. And then if I move to the traceability screen, then I will see that all the traces involving the element that has been removed will be shown in a different way with a different background color, giving me the possibility to remove all of them, or at least to filter and study in detail what would be the impact of this removal.
Okay, so let's finish here. Thank you very much, Jose, and thank you everybody for attending. If you have any additional questions or want more information about our tools, don't hesitate to contact us by email directly to Jose or to contact@reusecompany.com. You can also find information and videos on our website, reusecompany.com, and on our YouTube channel at The Reuse Company. Thank you and goodbye.
Thank you. Goodbye.